All right, so these are the properties that you really use when you're doing logs and exponentials, okay? So I just wanted you to get a an understanding, and we've talked about this. This property says for exponentials, if the bases are the same, and this is Palmer's, okay? If the bases are the same, then you can take their exponents and set them equal to one another and solve it, right? But you got to get the bases the same. That's the key for an exponential. But if you can't get that, then we're going to show you what to do. And this is take a log. If you're solving a log, convert it back over into a what? Exponential. We saw that in 6.3, did we not? Convert it over and there was some of that we just had to take the base raised to some power, right? It's like log base 5 of x equals 1.3 or something like that. Some craziness. Okay. And there's also, let's see if they have this property. Yeah. So I told you exponentials and logs are inverses of one another, right? So yeah, if you could take the bases of an exponential and just if they're the same, you can set their exponents equal to. If you have a log with the same bases, then you can set their ofs, right? But that's if and only if the bases are the same, right? Now always check to see if your answer is correct because and make sure it's not an extraneous solution, right? Why? Anybody know why? It's the one thing you can't take the log of. That's exactly right. You might solve for something, okay, but plug it back in. Like you may say, take the log of 2x minus 19, right? Solve that, right? And then you solve for x, and you end up having one answer, and you plug it back in. It gives you a negative number, right? You can't do that, all right? So I don't think we're going to go that deep, but just kind of be familiar with that. Now, one other thing you need to make sure you understand. If you can't rewrite exponentials to be the same base, then you'll take the log of both sides. Okay? And we'll show you how to do that. That works 100% of the time. Okay? Getting the bases to be the same only works when you can get the bases to be the same, right? Rewriting powers, like, okay? All right. So here we go. Hey, look at this one. Look at those. That's exponential, right? Look at those bases. What do you know about them bases? It's all about the, no. Wait. Show me the money now, right? Yes, he showed me the money. No, it's all about the money. Hold on. All right. So, huh? No. Nope. All right, so the bases of the exponentials are the same, right, guys? So we can sit here and do this. 3x equals 2x minus what? 4, right? And then you can just solve it, and you get x equals negative 4. And x is negative 4 is your answer. Questions? You okay with that? Okay. Huh? All day. Okay, well, let's step it up. What about that one up there? Yeah, you can. You can. You use the properties of exponents. Lord have mercy. You you got to think about powers of 2s, 3s, and 4s, as well as 5s. 2's up to about a power of 6. 3's up to a power of 4, 3 to 4. 4's up to a power of 3. And then 5's up to a power of 3. If you're familiar with those, then you can rewrite bases pretty good. Okay, I can rewrite this if my memory serves me right. I can rewrite this two ways and still get the same answer. Just depends on what base you want to go to. Okay. So we got 4 and we got 64, right? Okay. You want to try 15 seconds, 20, 30 seconds? No, you just want me to show you? Lord have mercy. She just knows she's not going to get it right. Oh, yeah, little faith. All right. Gotta have the faith of a mustard seed, right? Small. All right. So I can rewrite 64 as a power of 4, right? I could change these over and rewrite them as bases of 2. I don't want to do that. Okay, and I'd still get the same answer. It'd just be a lot more work. So I look at something and I go, okay, can I take that base and rewrite the other one in terms of that, in terms of power? And I can write 64 as 4 cubed, right? That's 64. Now, that's also being raised to the x plus 1, right? Now, what you have to make sure you understand is you brought back in those properties of exponents, and it's the power to a power. When you have something that's raised to a power, raised to another power, then you multiply these. So these are really I normally do that. And the reason why I don't distribute it through at this process, what happened? Huh? Where? Oh, no. The what now? Okay. All right. So I rewrite 64 as 4 cubed, right? So that took care of 64, but that 64 is also being raised to x plus 1. So you're going to multiply these, right? So that's why I wrote this 4 raised to 3 times x plus 1. I don't want to go ahead and, some of you might, and that's fine. I don't, because there's too much going on. I'd rather distribute when I'm sitting here. Now I've got bases that are the same. Now I can do this. Uh-oh. Now I can distribute. And solve it. X negative 4, right? Now, how do you know if that x is negative 4 is correct? You can plug it back in. Left side should equal the, after you get done raising it to the power, right? Whatever it said to go to, right? Okay. Yeah, back into the original, yeah. You always go back into the original because you have no copying errors there. And as long as it's written down, you don't have any copy error. I mean, if you rewrite it, then you have a chance for copying error. So, all right, any questions there?
Like when you go to put it back in, like if I put negative 4 back into
So it'd be negative 4 plus 1, which is what?
negative 3.
Negative 3. So 64 raised to negative 3. We know that would be a fraction, not a decimal, because of negative exponent. So 2 times negative 4 is negative 8. Minus 1 is negative 8 minus 1 is negative 9, right? So 4 raised to negative 9 should be the same as 64 raised to the negative 4, right? Or 5. What is it? 3. Sorry. I can't do math tonight. Sorry. Yeah. Oh, well. All right. Y'all good? I've got the same base, right? Y'all agree I got the same base? But what do I have to do with this part right here? I can't get rid of it. I've got to, no. Yeah, I've got to rewrite it as a fraction of a power, right? Because I need to keep that base 7 there, right? So here's the 2, right? You remember this? We said what? X A over B equals that, right? You remember that? Yeah? Yeah, it's just like yesterday. It's all coming back, right? Okay, so now I got 7s, right? The bases are there. So now it's 3x equals 1/2, right? So I will turn around and divide both sides by 3. So x equals here, there. So that's B, and there's A, right? And the A is 1, right? Here's a 1, and here's a 2, right? 7, right? And so I've taken these and putting this on the bottom, that's on top, right? Yeah. So that's 1/6, correct? I highly recommend what I just done right here. Unless you just put it in calculator. I mean, calculator do, I don't know, 0.5 divided by 3. Yeah, I'd do it all day long. Yeah. Well, but if you hit math and then hit enter, it'll take it back into a fraction. And there's also little keystroke buttons. Like if you hit the green, I think green, that one, or green y equals. It's green y equals. Right there, look, the green, and then the y equals button. It'll pop up a menu. It's pretty cool. You can do fractions. It's shortcuts. Yeah. Anyway. Okay. Y'all ready?
Please, convert fractions or decimal to a
Yep.
fraction.
The button right above the enter is a catch the wave type thing. So you could type 1 divided by 2. Enter. No, you have to hit enter.
Yeah.
You have to hit enter. Okay. Now, what did he give you guys?
0.5.
Okay, now hit the button above it. If you hit the, and it'll give you back as a fraction. So that, and you hit the button again, and it'll go back to a decimal. So that's how you do that. Yeah. You turn it on.
No, I know. Cool stuff like that.
Oh no.
I don't know the last time I've used a calculator, so.
Yeah, mine was about 2 hours ago.
Well, I mean, since this class, before this class.
All right. Okay. So x equals 1/6, right? All right. Oh man. 10 raised to x equals 4. There's no way I can get 10 and 14 to be the same base, can I? Can you? Not even with prayer can you get it to be. So, yeah, we're okay. We're going to take the log of both sides. So you just go log of 10x equals log of, guess what? 14. Now, remember those properties that we just got done doing? This is really cool. You take that x out, so it's x times the log of 10 equals log of 14, right? Now this is awesome. I don't care who you are, this is great. See, that log and that x are tied together by multiplication. So if I want to get rid of them, I just divide both sides by the log of 10. And that will give me x, which is make sure you close parentheses when you type in log, right? It is wonderful. Yeah, man, it's great. I got 1.1461, right? Yeah.
Like 1.15, you have to put 4 decimals.
I went to 4. Just my calculator went to 4. You can change it. Hit mode,
Oh.
and then second mode to quit. Anyway, yeah, it's crazy. It's a lot of capability right there in that calculator. Okay, that's how you do it. That's how you solve it. And the really cool thing about this, guys, on those previous problems, guess what we could have done instead of making the bases be the same? We could have took the log of both sides, brought the power out, which would have the variable in it, right? And rock and roll from there, right? Okay. Questions? That's what I wanted to make sure you were exposed to. Because there's some of y'all that leave and take 11, 13, right? So I want to make sure that you're equipped enough to do that. I don't know. Not me. No. No way, no how. I've done my time. But I will tell you this, trig is probably one of the... Yeah, it is. It makes doing the math and solving stuff easier.
Because you already learned this stuff before.
I know. But it's pretty cool. And you get the laws of cosines, law of sines. Uh-huh.
I took the trig before, but they made me take this one, which is actually past 4, even though I had credit trig over transcript.
Yeah, that time thing normally plays a big factor when you come back. Yeah, they make you go back and take stuff. Yeah, there's something about money.
I needed to brush up anyway.
So, all right. Okay, so solve the equation by rewriting the exponential expression using the indicated logs, and then use the calculator to approximate the variable to 3 decimal places. Okay, so, all right, man, this right here I'm going to tell you, it's crazy. So we're going to do this one, okay? So we're going to take the log of both sides, right? Now, any questions about what I just done? Okay, now what about this? What if I took this out to the front, and that would be 3x minus 2 times log of 5 equals log of, guess what? 36, right? All right, anybody know what I'm about to do? What? Well, I could. You're right. There's 2 paths here that I could take. You could do that. You should get the same answer because you're not breaking any. All right. Yeah, I took that to the front, right? Because it's power, right? The power property of a log. Now, this is 3x minus 2 times the log, right? So in theory, we should be able to take and divide both sides by log of 5, right? And that would be 3x minus 2 equals log of 36 over log of 5, right? And then I got to turn around and do what? Add 2 and divide by what? 3. Now, it doesn't matter. Or you could distribute the log through, and that'd be 3x times the log of 5 minus 2 times the log of 5, right? What you want to do?
Divide by log of 5.
See what I created? Oh, in 8 weeks, see? Jeez. And they said it couldn't be done. Brainwashed y'all. Little nerds y'all are. So that was... It's a pocket protector. What do you mean you don't have one? I don't wear shirts with pockets in them. Huh? Nerd pride. Okay. I know. All right. So, all right. So, okay, we'll divide by log 5, right? So that leaves me 3x minus 2 equals log of 36 divided by log of 5. Uh-oh. I can't write that down there. That's bad. Now, I've got to turn around and I've got to add 2 to that. And then I also have to turn around and divide it by what? The whole thing by what? 3. Do y'all see what I just done there? So that's what my x is going to be. So I've done this in 2, well, I've done it in 1 step, but 2 things. I added 2 and divided by 3, right? So I add the 2, boom, and then everything's divided by 3. So I'm going to tell you something. In your calculator, this is how I would do it. Am I on? Yeah. We're live. Okay. So I would take log of 36 divided by log of 5. Enter. Then I would add 2, hit enter. And then I would divide by 3. So, ladies and gentlemen, give me the answer to how many decimal places? 3. 1.4 what? 1.409. It's the cleaning thing. All right. 1.49. Y'all agree? Yeah. Did you put the whole thing in and get it right? Yeah. There you go. Buy a lottery ticket. I understand that the thing is the jackpot's up, right? No? I don't think nobody hit it. Huh? Yeah, I just give a couple of dollars away. If you think of it like that. Can't win unless you play, right? Yeah, it is. So. All right. Any questions on that? If you want to nerd out, you could distribute the log 5 and then add 2 log 5 over and then divide everything by 5, right? I mean 3, and you'll be okay. I mean, if you really want to. Proves that you can get the same answer, right? This is why I love math. What?
You said the way you would enter it in your.
Oh, I'd do the purple first. Log 36 over log 5. Hit enter. Then I'd add 2. Hit enter. And then I would divide by 3. I would take each operation and chunk it. I would take control of the order of operations. Right? That's what I would do. Right. Okay. Snap. What about this one? Anybody? Well, let's first off, let's kind of look at this thing. I would divide both sides by what? I like that better, right? So if I divide it by 20, that's I think last time I checked, that's 5, right? Y'all agree? All right, good. Now, how do you get rid of an E? You take the natural log of it. What you do to one side, you must do to the what? Sweet. So I'm going to take natural log of 5 equals natural log of E to the 4t. We know that these two jokers cancel out, so it's natural log of 5 equals 4t, right? Then just divide both sides by what? So t equals natural log of 5 divided by what? 4. That's a property, folks. And the one thing I don't like about your formula sheet is they don't have the properties of not E's, natural logs on there. But I will tell you this. You can replace all the properties with logs with the word ln. and everything should work out good. All right. Any questions on this one? How many more we got? Man. I got to make this last 8:50. Not really. Okay. Which one do? No, I've given you enough tools in tool belt to go. The what now? You want to take it out, move it to the other side? I guess you could. What if I done this? Ah. Watch what I'm about to do. Well, okay. Okay. Let me back up, punt. That's going to be an easier route. Because watch what I'm about to do. Because I'd have powers. I'd have to do force and Q, and I don't want to do that. And then I should be able to do this, right? Yeah? If I factor something out, if I distribute it back through,
Why wouldn't it just, why are you multiplying it by 4 minus 3?
I ain't.
Oh, okay, yeah, threw me off when you read that now. That's just extra steps, though.
I know. But you got to see why. Okay, could you take 4e to 2t minus 3 and get 1e to the 2t? You most certainly can. But you're not going to see that unless I do what? If I just done that, you'd be like, oh, okay. How you know how to do that? Well, here, this is why. Do you see how I proved it? I'm left with two numbers, right? If I took an e to 2t out, that's 4 minus 3, which is what? Just 1, right? So now you know why you can do that. So if an e raised the same thing with a, that's a power, really. Then you're just, well, it acts really acting like a coefficient, right? So that's really broke down to this, right? Which we can turn around and now do, and these cancel. And I'm going to go up here so that we don't have to rewrite all the way over. So t should be the natural log of 2 divided by 2. And no, you can't say 2 divided by 2 is 1. Can't do that. Why can you not do that? No. It's the natural log of 2, not just 2, right? Okay. So what does it give me? 0.3466. Okay. Y'all good? Sweet. I'll look back through 6.6 just to make sure that I have culled all the craziness out. I have, but I just will make sure that I'll go back through. I'll look at it again. So, but it gives you opportunity to practice on those. Okay. All right, guys, here we go. Use the definition of a logarithm to solve the equation. Okay. Huh? Well, yeah. You divide both sides by 5, right? Because that's 5 times it, right? So that gives me log base 2 of x is equal to what? 2. That's how do you solve a log? Change it into a what? Exponential. Wait. My brain's jumping ahead of my writing. X is 4. You okay with that? The hardest thing to do is once you figure out what the first step is. Once you get that first step, then the ball's rolling, you're good. Because when you get from the black to the blue over here, you go, okay, well, I can do, it's just a log. Remember, I can't take log of both sides because it's already log, right? So how do you solve a log? You change it back into an exponential equation, right? Okay. Huh?
Yeah, the next one.
Really?
Yeah, it's a solve the equation for x. It's
See? Solve it for x. Huh?
all the numbers.
Yeah, solve for x, all real numbers. Yeah. Yeah. Thank you. Really? Oh. This one's not as hard. Guys, how you get rid of natural logs? Now listen, what you do to one side, you do to the other. In math, you're creating an equivalent equation, right? So I don't like them natural logs, so I'm going to kill them. Left with x squared equals 2x plus what? Ladies and gentlemen, what is that joker right there? That there be a quadratic. Yep. It's a power of 1. Oh, well, here's what I'm about to do. Why am I going to do that? Well, in order to solve a quadratic, it must be set equal to 0. Look at your highest power on your x. It's a 2. It's a quadratic, guys. So, yeah, they threw that in there just for grins and giggles. What multiplies to give you negative 15, but adds together to give you a negative 2. Ladies and gentlemen, there'll be a 3 and a 5, and the negative would go on the 5. So that's x minus 5 and x plus 3. If you got a TI-36X Pro, you just type that joker in right there and hit solve, and it'll do it for you. Because I'm raising both, doing E. E. If I had E's, I'd take the natural log both sides, right, to cancel the E. But if I got natural logs, they'd be the power of E. If I raise them to the power of E, then I'm good. You know, the very first problem we had E raised to ln of 2, and it's equal to 2 because E and ln cancel out, right? Yeah, it's this principle. It's that. That's the property. Yeah. So, all right. So that's x equal to 5 and x equals to what? Negative 3. All right. All right, guys.
When do you introduce training solutions into this?
I would. I'd check that, but as long as 2 times -3 is -6, but 15's bigger than anything that I'd get that's negative, right, from these two answers. So, yeah. But you could check it, and you need to check it. You just as sure as I say they won't give you a problem that's going to have an extraneous solution for the quadratic because they're algorithmically generated. It shouldn't, because they're hard coding 2 answers on this particular problem. Now they'll give you one that's just a simple one. Oh my, that's it? You got to be kidding me.